Exploiting insecure service permissions. In this video, or rather in this section, we're going to begin taking a look at some other Windows privilege escalation vulnerabilities or attack vectors. And to begin with, we're going to be taking a look at how to perform privilege escalation or to elevate your privileges by exploiting insecure service permissions. Now, before we actually get started with the practical aspect of this, we need to understand a couple of things with regards to Windows services and what exactly we are exploiting in terms of misconfiguration. So to begin with, what are Windows services and how do they work? Well, Windows services are background processes that run in the Windows operating system, typically or often with elevated privileges, given that, again, they run in the background and start up when the system starts up or when a user logs in. And with regards to Windows services, services can be configured to start automatically, manually, or be triggered by specific events. Now, many critical system services related to the functionality of the Windows operating system and also certain programs run with high privileges, such as local system, local service, or network service. So they are tied to service privileges or service accounts, which again pretty much are constrained to or not limited to, but you typically see them running under the privileges of local system, local service, or network service. And then in the case of programs or software that again have background services, you'll typically see them running under the account or the privileges of the user that installed that piece of software. And in most cases, it's going to be the administrator user or a user account that is part of the local administrators group, or simply put, a user with administrative privileges. So what exactly are we looking to do here? Well, we are looking to identify and exploit insecure service permissions. So insecure service permissions occur when a Windows service has misconfigurations in its access control settings, so ACLs, allowing unprivileged users to modify the service or its associated components. Some common permission misconfigurations include full control or write permissions. So if a service's configuration can be modified by an unprivileged user, this creates a security risk. So again, let's assume we have a program that has, again, runs as a service in the background, and it was installed by the administrator user, which means it runs under the privileges of the administrator user, but for some reason it was misconfigured, or it has insecure service permissions allowing standard users to modify various aspects of the service itself. For example, the executable the service executable, the actual path to the executable for the service, etc. But an attacker could change the service's properties, such as its executable path, to, for example, execute arbitrary code, or replace that particular executable with their own malicious executable, or a payload, or an MSF Venom payload, for example. And what that means is, if we're able to replace, let's say, the executable, the service executable, and we're able to restart the service, given the service's configuration, it'll try and execute the executable associated with that service. And if we've replaced that executable with something like an MSF Venom payload, then it'll be executed with administrative privileges or the privileges of the user account or the service account that owns that particular service. And in most cases, we're looking for services that are running or owned by, let's say, the administrator user or any user account with administrative privileges. You then have unquoted service paths. So if a service's executable path contains spaces and is not properly enclosed in quotes, an attacker can place a malicious executable in a specific location along the path, causing it to be executed when the service starts. So this will make sense when we get into the lab, but in terms of the actual process or methodology of exploiting insecure service permissions, this is typically what happens. So step one is identifying vulnerable services. So the attacker enumerates the Windows services on the target system to find those with insecure permissions. And in this particular case, tools like PowerUp, Access Check, or Metasploit can be used to automate this process. We'll be utilizing PowerUp in this particular lab demonstration for this video. But moving on, step two is analyzing the service permissions. This is very important. So the attacker checks the permissions on each service to determine if they allow unauthorized modifications. And this involves examining the service's security descriptor and ACLs, or access control list, to see who has right or full control. And if we, through our current non-administrative or standard user account permissions or privileges, if we as a standard user can actually modify certain aspects of the service, like for example the actual path of the service or the executable itself. Bottom line, we're trying to see whether we can modify or we can make changes to the folder or the executable path, just as an example. Step 3 is obviously to modify the service configuration. So if a service has insecure permissions, the attacker can modify its properties. For example, the attacker might change the image path, which is just another fancy word for saying the actual path of the executable, to point to a malicious executable or a payload, or an MSF Venom payload, etc., allowing them to execute the code with the service's privileges or the owner of the service and their privileges. And then finally restarting the service. So once the service configuration has been modified, the attacker restarts the service, and this causes the modified executable to run, leading to privilege escalation. If the service runs with administrative or system level privileges, the attacker's code will execute with those privileges. So that's ideally what we're looking at, or what we're looking for with regards to exploiting insecure service permissions. And this will become clear in the lab. So the technique we're going to be exploring is called service binary replacement or service executable replacement, where we identify a service with insecure permissions. So the attacker first finds a service where they have right access to the service's executable file or its directory. Secondly, we replace the executable. So the attacker replaces the existing service executable with a malicious executable, and the malicious executable might contain a payload to create backdoors, escalate privileges, or even give us some interpreter session. And I think where we're going with this. And finally, we restart the service. So when the service is restarted, it runs the malicious executable, allowing the attacker to execute their payload with the privileges of the service, often resulting in privilege escalation. And with that being said, we can now take a look at the actual process of identifying and exploiting insecure service permissions in order to facilitate privilege escalation on Windows. So this video has a lab environment associated with it, and the lab is just going to be below this video. And again, you can choose to go through the demonstration first or through the lab first. It's entirely up to you. I'm going to fire up the lab, and I'll see you there in a couple of seconds. All right, so I'm currently in the lab environment, and as you can see, it's going to be fairly similar to the previous lab environments, where you have your Kali machine and your target machine, which is running Windows, and you'll also be provided with your target machine IP address. Now, do remember again that your target machine IP address as well as your Kali Linux IP address will be different than mine, and consequently different for every time you start a new lab or you restart your lab. So just remember to replace my IP address from this demonstration with yours if you're going through the lab as you're watching this particular demo. So the first thing we're going to do is we're going to go into the Windows system, and we're going to utilize PowerUp. And we already have the Post-exploit folder right over here on the desktop. So I'm just going to open up PowerShell, and I will increase the font size here. So we'll give this a few seconds, like so, and we'll just wait for this to load up, and we'll change this to something like 28, and I'll navigate into the desktop and into PowerUp, or rather into Post-exploit, and then privesc, and within this folder we should have PowerUp.ps1. So we can firstly load PowerUp, and then we can then invoke the privesc audit function. So I'm just going to say, I'm just going to load up PowerUp. So PowerUp, or imported rather, like so. And my bad, I forgot to say PowerShell execution policy bypass. And now we can say load up PowerUp again, and we can finally say invoke privesc audit, And this is going to, we're going to use PowerUp to identify any insecure service permissions or services with insecure permissions. So I'll hit enter, and I'll get back to you when this is done. It shouldn't take more than a minute. All right, so PowerUp is done, and it looks like it's identified a service called FileZilla server here, and the check that was done is modifiable service files. We can see that the name of the abuse function is install service binary. The name is FileZilla server, and we can see that the path to the actual service executable is program files x86, FileZilla server, and FileZilla server.exe. Now, in terms of the modifiable path here, we can see this right over here. Actually, hold on. We can actually see that the modifiable path is this right over here, and the file permissions, we can see that the modifiable identity reference says that the user student, which we're currently using, it's a standard non-privileged user that we have access to, can make modifications to this particular file or this executable right over here. And the start or the privileges that this particular service runs with our local system, which again are pretty much the highest on Windows. And we can see that right over here that can restart is set to true, and the name is just FileZilla server. So we can pretty much modify this or replace this original executable with our own malicious one, or maybe an MSF Venom payload. So I'm just going to open up the Explorer here, and if I go into program files x86, we can see there's the folder here, and what we can replace is this executable here. So what we're going to do now is we're just going to check the service directory permissions to verify that we indeed can make modifications to the service executable. So I'm going to say get ACL, and we're going to say C program files, if I can type that in correctly, C program files x86, and FileZilla server, I believe, is the name there. And then we're going to pipe this and say format list. And now we can just hit enter, and we can see there we are. The owner is built-in administrators, so the administrators group. We can also see that the group, there's no group ownership here. In terms of access, we can see that the user student, or this account, the non-privileged account we have access to, has the following permissions. So allow full control. So that means we can make changes to the actual executable or to this folder in general. And we can consequently replace that executable with our own, and also start or restart the service. So what this means now is we can pretty much go into the Kali Linux system, and I am going to open up a terminal, and I'll just say I have config to identify my Kali Linux IP. So that's going to be the IP associated with the interface Ethernet 1. And I'm just going to copy that, and we're now going to generate an MSF Venom payload to get a Meterpreter session, an elevated one hopefully. I'm going to say the payload is a Windows Meterpreter reverse TCP, and the L host is going to be the Kali Linux IP. Again, remember to replace it with yours. And then I am going to say, sorry, let me just paste that in one more time. We're then going to say L port is going to be equal to 4444. The format is going to be exe, and we'll just output that to, we can just call it FileZilla server, the name of the executable. So we'll say FileZilla server.exe, and we'll then hit enter. And we're going to give this a few seconds. So the reason I'm using single quotes in the file name is to again account for the space in the executable name. So if I now list out, you can see we've generated it here, and we can probably also generate it without, without specifying the single quotes. And I'll show you how to do that. But from this point, what we can now do is set up the multi-handler in Metasploit. So I'll open up MSF console here. Sorry, I'll do this in quiet mode. And we will then just set up the multi-handler to receive the meterpreter session or the callback. So I'll just say use exploit multi-handler, and we'll set the payload to the payload we used when generating the MSF Venom payload. So payload windows meterpreter reverse TCP, set L host to the Kali Linux IP. In your case, make sure to replace it with your own. And now if I say show options, we can see that that's set correctly. What we can also do is set up an initial auto run script. So I'm going to say initial auto run script. Do we have this functionality? We should have it. So initial auto run script, and we'll just say post windows manage migrate, just so we can migrate the process as soon as possible. Let me make sure I put or format this correctly. So set initial auto run script. Yep. So it's going to migrate the process to a different process ID. That's because if the service stops unexpectedly, we lose our meterpreter session. And I'll now hit exploit to set up the handler. And I'll now create a new tab. And again, still in the folder where we generated FileZilla server.exe, I'm going to set up a simple web server to host this payload. And I'm just going to say Python. We'll use the Python module simple HTTP server. And we'll host it on port 80 on the Kali Linux IP address. So we're now hosting a web server on the Kali Linux system on port 80, so we can download this executable onto the target system. So I'll now go into the Windows target, and I will now say within PowerShell, we can use IWR, use basic parsing, and the URI is going to be HTTP, the IP address of the Kali Linux system, which again I'll need to copy one more time. So let me open up a new tab here, and it's 10.10.83. So I'll just paste this in here. Okay, it doesn't look like it's working, but I can say 10.10.80 and 3, and the name of the executable is file Zilla server.exe, and we'll close that single quote. So we're getting and we're downloading it from the web server that we have set up with Python, and we'll then say the out file, so where we want to save it, and that's obviously going to be program files x86. So we're just replacing the original executable with our own malicious one, and that's under FileZilla server. And we're then going to say the name of the executable is just going to be the same, FileZilla server.exe, and we'll close that single quote there, and I'll now hit enter. And now we can see that if we check that folder, we should have replaced it, and you can check the timestamp to see whether that did it successfully. But there we are, you can see it replaced the original. The original had an icon just like this server interface executable, and this is much smaller. It's about 73 kilobytes. So from this point, what do we need to do? We need to restart the service. Now, again, if you had a meterpreter session, you can easily utilize the net start functionality or the SC command to restart the service. But given that we have RDP access here, I can just open up services, and I'll just give this a few seconds here to load up. As always, Windows services.msc, and we'll find the FileZilla server service, and we can restart it. And there we are. So I'll give this a few seconds, and we'll just wait for that to load up. There we go. And I'll now just maximize this, and we're looking for the FileZilla server. So EF, there we are. We can see that the startup type is manual, so we can just click on start. Now we will get an error, and that's because the original executable has been modified. And again, the meterpreter payload or the MSF Venom payload is not a service, so it's likely that given the service configuration that this will fail, or it'll still start it, but we probably will get an error. Now, if we go back into our Kali Linux system and we go into our handler, you can see we immediately got a Meterpreter session. And if I say sysinfo, you can see it actually closed. That's very weird because, hold on, we migrated. If I say sessions, hold on. Yeah, that's very weird. So if I now say exploit and we run it again, we'll need to migrate very quickly. So there we are. So I'll just start it again. And we get a Meterpreter session, pgrep, or we can just say migrate nexplorer.exe. I'm just doing it a bit faster so we can migrate. There we go. That should do it. And now, regardless of whether the FileZilla service is active or stops unexpectedly, we shouldn't lose our Meterpreter session. And more importantly, if I say get user ID, that's very weird. We can see that it that's very strange. Yeah, okay, so it's still with the privileges of student. So if I say get privs, and I think I know what the issue is here. We migrated to Explorer under the context of the user student. So let me just start up or terminate this Meterpreter session and then restart the service. All right, so I've set up a new handler and we're going to click on the service and click on start again and get a new Meterpreter session. And now I'm going to say migrate lsas.exe. And hopefully this gives us a session. So if I say get user ID now, there we are, NT authority system. So the reason why when in my Meterpreter session 2, we still had the privileges of the student user is because I migrated to the process, the explorer.exe process associated with or running under the privileges of the student user. But in this case, I migrated to lsas.exe, which again is responsible for authentication on Windows and again runs under the highest privileges. So there we are, we can see NT authority system. And if I say get privs, we now have an elevated session. You can obviously follow along with the lab and get the flag, but that is how to exploit insecure service permissions for privilege escalation on Windows. And again, you can go through this lab in your own way, where you can obtain a Meterpreter session traditionally for initial access, and then perform what we just did through Meterpreter instead of using the target machine and the RDP access. But again, that's entirely up to you. With that being said, that brings us to the end of the practical demonstration section of this video.